Welcome to a webcast produced by the Learning Enhancement team based in the Dean of Students office at the University of East Anglia. This webcast is part of the Steps into Trigonometry series and concerns an introduction to triangles. This guide introduces some of the terminology associated with triangles and some of their basic properties. This guide also lists the different types of triangle. Introduction. A triangle is a shape which you should be familiar with, as they are one of the most important shapes in mathematics. A triangle has three sides and three corners, giving three internal angles, and can be completely described by the lengths of the three sides and the size of the three angles. The mathematical study of triangles is known as trigonometry, often abbreviated simply to trig. The word is derived from the Greek words trigonon, meaning triangle, and metron, meaning measure. The rigorous investigation of triangles has resulted in some of the most fundamental and far-reaching theorems and rules in the history of mathematics. It is important that you are familiar with some of the basic words and properties of triangles and trigonometry if you are to become successful in any study of mathematics at university. This guide gives an overview of the terminology involved in describing a triangle and a description of the different types of triangles you may come across in your studies. Describing triangles. There are many, sometimes confusing ways of writing down the sides and angles of a triangle. Let's use the triangle below to explore the way that sides, angles and triangles themselves are denoted in mathematics to try and clarify why mathematicians write what they write. You can think of a triangle as the shape formed when 3 points, which are not in a straight line, are connected by straight lines. The points in a triangle are conventionally labelled using three concurrent capital letters, in this case A, B and C. You may see the triangle itself represented by the symbol triangle ABC. The sides of the triangle link the points and are written in a variety of ways. For example, you may see the line linking the points A and B denoted by AB, or equally BA. Alternatively, the line can be represented by a single character which is connected to the point which is opposite the side in question. Look carefully at the triangle above. Can you see that the point C is opposite the side AB? Similarly, A is opposite BC and B is opposite AC. The relevant side is conventionally labelled as the lowercase version of the opposite point. So, AB is opposite C and can be labelled C. Similarly, BC can be labelled A and AC is labelled B. The angles in the triangle can be denoted in a variety of ways. Usually, lowercase Greek letters are used, specifically theta, then phi, and then gamma are used if 1, 2, or 3 angles are unknown. An alternative and quite common way of denoting an angle is describing the path to take to make the angle. For example, to make the angle theta in the triangle above, you could trace the path from B to A to C, or equally C to A to B, and this is written as angle BAC or angle CAB. Properties of triangles. 1. The interior angles of any triangle sum to 180 degrees. This means that you can calculate the size of the third angle of a triangle when you know the size of the other two. 2. The area of a triangle can be calculated if you know the length of the base of the triangle and its height. It is given by half the base multiplied by the height, or area equals a half times the base times the height. You can use any side as the base. The height is the distance to the peak of the triangle when the triangle is laid on the side you use as the base. If you do not know the height of the triangle, you can use Heron's formula to calculate the area of the triangle. For a triangle with sides of length ABC, the area is equal to the square root of S multiplied by S take away A multiplied by S take away B multiplied by S take away C, where S is the semi-perimeter of the triangle and is given by S equals A plus B plus C all divided by 2. 3. The sum of the lengths of any two sides of a triangle is always longer than the length of the other side. This is an important property of triangles known as the triangle inequality. 4. Triangles which have the same lengths of sides and sizes of angles are said to be congruent. 5. Triangles which have the same three internal angles in the same order are said to be similar. Types of triangles. Type 1. An equilateral triangle. In an equilateral triangle, all the sides are of equal length. This also means that all the angles are of the same size, i.e. 60 degrees. To indicate that the sides are of equal length, a small line is put through their centre. An equilateral triangle is a regular polygon. Type 2. An isosceles triangle. An isosceles triangle has two equal sides with the line through and two equal angles, here shown by theta. It is useful to note that 2 theta plus phi is equal to 180. Type 3. A scalene triangle. A scalene triangle has three unequal sides and three unequal angles. Type 4. A right-angled triangle. A right-angled triangle contains an angle of 90 degrees, the right angle, and implies that the sum of the other two angles is 90 degrees. A right angle is depicted by a small square within the triangle. Right-angled triangles can be either isosceles, with the two other angles equal to 45 degrees, or scalene. Right-angled triangles are very important in mathematics. They led Pythagoras to formulate his famous theorem and are the basis for the definition of the trigonometric ratios sine, cosine and tangent. See the study guides on Pythagoras' theorem and trigonometric ratios sine, cosine and tangent. Type 5. Other types of triangles. There are other descriptions for triangles which are not as common as the previous four. A triangle which does not have a right angle in it is known as an oblique triangle. A triangle in which all interior angles are less than 90 degrees is called an acute triangle. An equilateral triangle is both oblique and acute. Finally, a triangle which contains an interior angle larger than 90 degrees is called an obtuse triangle. Further guidance and information. If you have any further questions about trigonometry or would like to discuss any other aspects of mathematics, you can talk to your lecturer or personal advisor or make an appointment to see a learning enhancement tutor in the Dean of Students office. You can telephone 01603 592761, email dos.help@uea.ac.uk, or visit our website at www.uea.ac.uk/dos/let. There are further resources on many other aspects of numeracy, mathematics, statistics and science available from the Dean of Students office and on its website. These include questions to practice, model solutions and webcasts illustrating essential skills. This guidance is one of a series on mathematics produced by the Dean of Students office at the University of East Anglia.